So see, till now we were discussing about your determinate structural analysis, where we have discussed for the analysis of plane frames or total frames, and then we have discussed about analysis of three hinged arches, which is basically a determinate structure, and then we have discussed about in detail the analysis of cable. Okay. So after this discussion, let us now start some discussion about the analysis of indeterminate structure. Okay. So see, analyzing indeterminate structure is basically not that difficult, but you need to understand the philosophy or the concept behind analyzing any indeterminate structure. Okay. So if you see in your syllabus, it is given that force method of analysis you'll have to apply for analyzing indeterminate structure, and up to 2 degrees of freedom you'll have to go for analyzing any indeterminate structure. So I hope that you understand what is degrees of freedom and how to find out indeterminacy of a structure, right? So that is being discussed by madam in detail. Now you see, when you try to analyze any indeterminate structure, you must understand indeterminate structure means what. Indeterminate structure is essentially a structure where you have unknown component of reactions or unknown component of internal forces. It's not only reactions, either it may be external component of unknown reactions, or it may be the internal forces of any member, okay, which are unknown when you apply the equilibrium conditions. That means not equilibrium conditions, I should not say equilibrium conditions, when you apply the equation of statics basically. So the equations of equations for statics for equilibrium, that is sigma fx equal to 0 and sigma fy equal to 0 and sigma mz equal to 0, which is being necessarily applied for any two-dimensional structure. If you apply those three equations and you are not able to find out the unknown component of reactions or internal forces in any structure, those structures will be considered as indeterminate structure, right? And when we are talking about this indeterminate structure, in that case, you see, you must understand one thing, that before a structure is being considered indeterminate, it must be stable. See, suppose there is a structure which is supported on multiple number of rollers. I think I have given you one example also. I don't remember whether in this whether in your class or in the previous year I have given that example. I don't remember. See, suppose there is a truss bridge, and the truss bridge is supported on multiple number of rollers, only roller support. So you see, you will see that multiple number of rollers means, let's say a truss bridge is supported on 4 number of roller support. Okay. So you see, 4 number of rollers are going to give you 4 vertical reaction components. That's all, right? So from the equation of statics, you should be able to solve 3 reaction components, right? But the 4th one you will not be able to solve. However, you see, when you will get such kind of structure, although it looks to be indeterminate, it may not be stable. Because you see, when a truss structure or any structure will be only supported on a roller, then you see, the structure is not essentially remaining a structure. Only a little horizontal push from the horizontal direction will make the structure in a moving condition, right? So the structure will become mechanism. I think I have discussed this while discussing in engineering mechanics only. No, I don't think I have taken your engineering mechanics, maybe the other class I have taken. Okay. So you see, in that case, you try to understand this, that a structure essentially will become indeterminate, but before it becoming indeterminate, it needs to be stable. So, a structure which is essentially an indeterminate structure, but it is not stable, we will not consider such kind of structure as indeterminate structure. So, stability is the first criteria, that's what you must understand. Okay. So, a structure necessarily should be stable before it is indeterminate. Okay. Now, with this introduction, let us try to understand how do we analyze any structure, indeterminate structure, using force method. But before going to force method of analysis, we will try to discuss about things or the concept behind force method of analysis of indeterminate structure. So, you see this force method of analysis of indeterminate structure, if you see, this is basically what actually you will have to do. So, everyone can see my screen. Is it visible, or should I make it little larger?
Yes, sir. Visible, sir.
So, if I make it little larger, will it be better? Is it okay now? Can you view it?
Yes, yes, sir.
Yes, sir.
Okay. So, you see, so any indeterminate structure, if you see, that can be analyzed or that can be solved necessarily by two methods. You see, all the structural analysis methods, whatever you see in structural analysis books and other places, if you see that those methods, whatever may be the method, okay, that can be broadly classified under two categories. So, any indeterminate structure can be solved by how many methods? By two methods. Okay. So, what are those two methods? So, these two methods, when you are saying, see, one method, the first method is called force method. Okay. The first method is called force method. Okay. So, this is your force method, and the second method is basically your displacement method. Okay. So, force method and displacement method. Now, necessarily you need to understand what are these two methods actually. So, see, you should be very clear about this concept, because you see, in many cases, many questions in the competitive exams and your interview questions and all, this is being asked very specifically. What is force method and what is displacement method? What is the difference between force method and what is the difference between displacement method? Okay. So, let us try to understand the concept behind force method and displacement method first. This is very simple to understand, I will tell you. See, in force method, what is happening, you see the name will also tell what is this force method exactly about, and the name of the displacement method will also tell about what is displacement method. So, you see, the force method has got other names also. The other name of the force method is flexibility method. So, there is the name is given flexibility method, or the name is also given as compatibility method. Okay. So, same, if you see what is the force method, the flexibility method, the compatibility method, they are necessarily the same method. You must understand this. Okay. So, when you are analyzing an indeterminate structure using compatibility method, that means you are analyzing it by force method. Now, the question is, what is force method? What is flexibility method? What is compatibility method? Okay. So, everything is same. They are not different. So, whatever is force method, that is flexibility method, that is compatibility method. Now, we will try to understand what is then compatibility method. So, if you necessarily understand what is compatibility method, you will be able to understand that is flexibility method, and obviously that flexibility method will be force method. Exactly the same way, if you consider the displacement method, so the displacement method necessarily are also termed as stiffness method of analysis. It's a very important thing, stiffness method, or it is also called as equilibrium method of analysis. Okay, equilibrium method of analysis. Okay. So, till now whatever I told you, have you understood? So, see, the basic two methods or I will not say basic two methods, the broad categorization of solving any indeterminate structure can be divided into two categories only, or two methods only. They are force method and displacement method. So force method is necessarily nothing but your flexibility method or compatibility method, whereas your displacement method will be called as stiffness method or equilibrium method. Is it clear? Okay. Now let's see what is force method and why this is called as force method. Why the name of the force method is given as flexibility method or compatibility method. So what is being done necessarily in force method, I will try to explain. See, in the force method of analysis, what is being done? Force is taken as unknown. This is very important thing. So the unknown component is force in the case of force method of analysis. You must understand this. Okay. So force means what? Let us take one example, then you will be able to understand it. Let's take a prop cantilever. I'll just take another one page and I'll draw it, so you will be able to understand it in a better way. So let us take a prop cantilever. So I will just draw quickly the diagram. You please consider these as fixed support. So let's say this one is the fixed support. So a prop cantilever. See, this is a cantilever beam, isn't it? This is a cantilever beam. Okay. So in a prop cantilever, what I will do? What is the prop cantilever? Can anyone tell me? Tell. So at the end of the beam or anywhere somewhere between the beam, I will put another one support, right? So let's say I put another one support. Let's say at this position, let us say I put a pin support, or let us put another one instead of this. Let's say I put a roller. Let us put a roller support. Okay. So let's put one roller support over here. So if I put a roller support over here at the end of the beam like this, so this is actually a prop cantilever. Okay. So please bear with me. This roller support I have drawn little bit larger just for your explanation. So it's something like this. Okay. So you now have understanding about prop cantilever. So now you see, suppose this kind of beam is called as a prop cantilever. Now let me tell one thing. Let me ask you one thing. Suppose I don't have this roller support over here, and I put one load, a point load over here, let's say. So you tell me whether this structure is determinate or indeterminate in this case. Anyone? Are you listening or not listening? Hello?
Yes, sir.
See, are you listening or not listening? I am a little bit confused. See, when I ask any question, this is what I have seen yesterday's class also, civil 1, I think. Okay, same thing, no response. What I am asking? Whether this structure, whatever I have drawn, are you able to see whatever I am drawing in the screen?
Yes, sir.
So this is basically a cantilever, right? So cantilever beam. So I am asking whether this is a determinate structure or indeterminate structure. This simple question you cannot answer. Is it determinate or indeterminate? Tell me. No answer. क्या हो गया? Anuj, Abhishek, no one can answer. This cantilever beam, Buddhadev, Dibakar, everyone is here. I see. Okay. Rama is there, Mainak is there, everyone is there. whether this structure is a
Yes, sir.
determinate structure or indeterminate. Please tell. This structure, whatever, can you see this structure, whatever I am showing here?
Yes, sir.
It is a determinate structure or indeterminate structure?
স্যার জানি না
কে বলছে এটা জানি না?
স্যার মইনা
মইনা কেন? See, these are very simple questions you are not able to address. So after teaching so many things in structural analysis, you cannot say whether a cantilever beam is a determinate structure or indeterminate structure. Anuj, tell me. Buddhadev, tell.
Indeterminate.
भूल गए हैं।
ইনডিটারমিনেট স্যার
Huh?
So indeterminate structure.
Indeterminate structure. This one is the indeterminate structure, whatever I have drawn. See, what is the definition of indeterminacy? See, I am very sorry to say that you people are not at all in touch with your studies. That is what is happening. I am seeing.
सर नंबर ऑफ रिएक्शन माइनस नंबर ऑफ इक्विलिब्रियम इक्वेशंस।
So see this structure in this the plain simple cantilever structure. How many reactions you will get? See, it is very pathetic to
Two,
see.
sir.
See, this is there will be a vertical reaction over here. Okay, and then what will happen?
Two.
There will be
Momentum,
a
sir.
horizontal reaction, but no, in this case there will not be any horizontal reaction coming, because you see there is no horizontal load acting on this structure. So I may keep it or I may not keep it, and there will be another one thing which is nothing but your moment, right? So there will be a moment at this point.
सर हॉरिजॉन्टल को लेंगे कि नहीं लेंगे?
See, take it or don't take it, doesn't matter, right? Doesn't matter actually. So there will be a moment. See, moment drawing is difficult. Just a minute. Circle, where is the circle? So there will be some moment like this, right, at this point. So these are the three things you will be having for this structure. So how many equilibrium equations you have? You tell me. How many equation of equilibrium you have? So there will be a vertical
Three, sir.
reaction, there will be a horizontal reaction, there will be a moment. Any other reaction will be coming in this structure? No. So there are three reaction components, and how many equation of equilibrium you have from statics? You have sum of
Three.
3. So you have sum of fx equal to 0, summation of all the forces in the x direction equal to 0, summation of all the forces in the y direction equal to 0, and summation of all the forces in the summation of all the moments about the z axis equal to 0. So those actually in mathematical term we call it sigma fx equal to 0, sigma fy equal to 0, and sigma mz equal to 0. So three equations of equilibrium from statics, and you have three unknown reaction components. Two reaction components, one is vertical reaction, one is horizontal reaction, and another one is moment. Okay. So 3 minus 3, it's going to be 0. So this structure is necessarily a determinate structure. So you see a simple supported beam, a simple cantilever beam, a 3-hinged arch, a cable, a portal frame which is having such kind of structural arrangement where number of unknown reaction components equal to number of equilibrium equations from statics. All those structures will be called as determinate structure. Okay. So once you see this determinate structure, you can very easily analyze. But you see, this structure is necessarily a cantilever beam. When I say I put a roller support at the end of the structure. Let's say I put a roller support at the end of the structure. Then what will happen to the structure? If I put a roller support at the end of the structure, then what will happen? Will there be 3 unknown components, or there will be some more unknown components adding to it?
One unknown components added, sir.
One and
Four, sir,
another
four.
unknown component will be added up. Absolutely correct. So what is that unknown component? Because of this roller support, whatever you have, because of this roller support, actually at this position of this roller, if I remove this roller, actually there will be another one vertical reaction component coming over here, isn't it? So you see, now in this structure, so necessarily this structure now will be called as what? It will be termed as, basically it will be termed as propped cantilever. Okay. Now once this structure is just added with this roller support, something like this, then you see this structure cannot be now analyzed using those 3 equations of equilibrium from statics, because now you see number of unknown components, the unknown reaction components. So see, unknown, if I say unknown reactions, so reactions means, you see, reactions means you must consider here internal as well as external, internal as well as external. Now you see, in this case, if you think from this structural perspective, we are just considering the external reactions, and when you are talk about reactions, you must understand reactions means those vertical, horizontal reactions as well as the moments also. Okay, moment also will be taken in a common or generic term as reaction only. Okay, so this structure, this propped cantilever, if you see, in this case, you see there are 4 unknown, right? So there will be 4 unknown components, right, for this propped cantilever. So how many unknown components you have? 4 unknown. What are those 4 unknown components? What are those 4 unknown components? So you have vertical reaction at where? Vertical reaction at fixed support, right? Vertical reaction at fixed support. Then you have horizontal reaction at fixed support, and what you have another one? You have moment at the fixed support. Also you see, you have another one reaction component. What is that? Vertical reaction at the free end, which is called basically the PROPPED, propped end. So at the propped end you have another one vertical reaction. So you have 4 unknown components. Now these 4 unknown components, you see, all these components are what? Necessarily they are unknown reaction components, right? Unknown reaction components. And you see all these reaction components, whatever you see, this one, this one, this one and this one, all these 4 reaction components, these unknown reaction components are necessarily, if you see, they are external. They are not coming from any internal force component or internal force from the structural member. Rather they are external forces or external reactions, right? So these external forces and reactions can be knocked off only by, you see, 4 unknown, and you have 3 equations of equilibrium. So what are those 3 equations of equilibrium? You understand what are those 3 equations of equilibrium? So once you have 3 equations of equilibrium, so 4 minus 3, 4 minus of 3 is equal to 1. So you will have one unknown which you cannot solve, unknown which you will not be able to solve using the equation of equilibrium, or rather you can say equation of static equilibrium. So I can say static equilibrium. So if you cannot solve this structure, so this unknown, out of these 4 unknown, if you cannot solve for one unknown, then the structure is not solved. So until and unless you find out all the 4 reaction components in the structure, you will not be able to draw the bending moment diagram or the shear force diagram of the structure. So if you cannot find out the bending moment diagram and shear force diagram of the structure, you cannot basically, finally your structure will not be basically analyzed, and you will not be able to finally design the structure as well. So to overcome this, actually these methods, whatever we will be discussing now, those methods are coming. So now let us go back again to this part. So you see, in the force method of analysis, I have come from this point. The force is taken as unknown. Now you see this structure. So if you see this propped cantilever, you see all these are forces. See, I have written it over here also, that unknown reactions. So either they are external forces or reactions. Okay. So basically in force method of analysis, all the forces are taken as unknown. Correct? So forces will be taken as unknown, and the equations will be obtained using compatibility. Equations will be obtained using compatibility. This term is very important, and that is why the name of this force method is given as compatibility approach. Now the question you may ask, what is compatibility then? Now I will explain this. Compatibility is a very simple thing for that propped cantilever only. Let's say, suppose, just a minute, Now you see, this force method, in the force method, you see the force is taken as unknown, I was telling, and the name is given as compatibility. Now you should understand what is this compatibility condition. See, don't go with the name, it's very simple thing. Okay. See, very simple, you should understand this. Let's say, think about this structure only. Think about this structure. Okay. Now you see, suppose this is a cantilever structure, and let's say this is a propped cantilever structure. Now let's say, if I remove this prop from here, let's say I don't have this prop at this point. So what will happen to this structure if I remove this prop from this structure? Will this structure become unstable or it will remain stable? Bolo?
Unstable.
It will become unstable.
Deflected at free end, sir.
So what? See, if I remove this prop from here, it will become a cantilever.
Stable, sir.
It is stable.
Stable, sir. Cantilever
See,
beam.
you should not get confused. Okay. See, it will become a cantilever beam. It is just a cantilever beam. So 3 unknown components you should be able to solve using 3 equation of equilibrium. Okay. So you see, it is necessarily will remain a stable structure, and you see, first thing you should understand here, see, after removing this propped reaction, if I remove this propped reaction which was ideally over here, you see, if I remove it from here, what is happening? Basically the structure remains stable, and you also observe another one thing, the structure has now become a determinate structure. The indeterminate structure with that prop condition has now become a become an indeterminate structure, a determinate structure. Okay, so this structure is now determinate structure. Now because of this load, because of this point load, what will happen? Because of this point load, what will happen? This structure will deflect, right? So it will deflect downward. So if you see the deflection pattern, it will be something like, so there will be some deflection over here, something like this. So the structure will be getting deflected in this way, right? It will be just going, it will be touching over here and it will be going down something like this. So it's the cantilever, so zero deflection over here and there will be some deflection at this point. Okay, now because of this load, this deflection is coming at this point. Now you should understand one point very clearly, that is that if a prop is being put under here, or a support, a roller support is being put under here, will there be any vertical displacement of this structure? Will there be any vertical displacement over here?
No, sir.
No, absolutely there will not be any vertical displacement. Okay, and that is what is the compatibility condition. So you see what it can be done, I can just remove these three reaction components. You see, I can just remove these three reaction components and I can remove this vertical load from here. Now when I consider this structure, you see this is now necessarily a cantilever structure which is supporting a basically unknown reaction component. This is actually unknown, this part, this reaction component is unknown reaction component, and because of this also the structure will be deflecting, right? So it will be deflecting. So how it will be deflecting now? So it will be now deflecting, you say it will be now deflecting somehow upward, right? So it will be deflecting upward. So how do I do? It will be deflecting upward. So upward will be something like this. So it will be difficult to draw here. Which shape should I take? Let me take this one. So you see this deflection will be now upward deflection means, how can I draw this? Let me draw with a straight line only. So the deflection will be something like this one. So there will be upward deflection at this point. Is it clear? So now you see what is compatibility condition. So when this support is not there, and when the loads are being, when the load is being acted upon on this structure, there are three reaction components over here. So there are three reaction components over here, and because of this load, or rather here it was acting, so you had some deflection which is actually getting downward like this, right? So because of this load the deflection was downward, so this much deflection must be equal to the deflection when the structure is not acted upon by all this load and only a propped reaction is acting on the structure, and because of this propped reaction it is again a cantilever and it will be having some deflection like this. So what will happen necessarily? Necessarily you see the deflection because of this propped reaction, which is actually unknown reaction force, the deflection at here and deflection at here must be equal. That means the sum of the deflections, so this deflection will be downward and this deflection will be upward. So if you take the summation of these two deflections, they must be equal to 0. If it is not 0, then what will happen? The structure will deflect at this point, which necessarily is not the case when physically you are considering the structure. Are you getting? So this is actually your compatibility condition. Have you understood it? Have you understood what is compatibility?
Yes, sir.
Getting? So you see, it's a very simple concept. So compatibility condition is nothing but a condition where you are applying some kind of force, okay, on the structure, okay. So some kind of force or deformation due to unit force, okay. So flexibility flexibility, if you think, so flexibility is basically the deformation due to unit force, okay. So when you are equating the deformations due to force and you are considering that deformations coming from one direction is equal to the deformation from the other direction, from the exact physical concept of the structure, from the support reactions of the structure, or from the stability of the structure, or from the concept of structural behavior, then actually what you are doing, you are applying compatibility condition, okay. So the one unknown component, see, so sorry, for analyzing this kind of structure, you see, for analyzing this kind of propped cantilever, so if you want to analyze a propped cantilever, then what actually necessarily is required, you understand, try to understand. So if it is a propped cantilever, something like this, then necessarily you require four equations of equilibrium, because you have four unknown components. So three three equations you will be getting from equation of static. The fourth one you will be getting from this compatibility condition. Are you getting? So this compatibility condition, now you have understood, the compatibility condition is nothing but the deformation being created by the forces inside the structure, and at particular point in the structure, from the physical behavior of the structure, you should be able to comment whether there will be deformation. Now this deformation, it can be vertical displacement, it can be horizontal displacement, or it can be also rotation. All the three things will be considered as deformation, okay. So this is actually your compatibility condition. So you must understand what is compatibility condition. So that is why this method is also called as compatibility approach. So the force method, now you should understand why this force method is termed as compatibility approach, okay. So this is why it is called as compatibility approach. On the other hand, we will not now get into the detail of displacement method. On the other hand, if you will observe that if you are analyzing a structure using displacement method of analysis, in such case, instead of force being taken as unknown, displacements are taken as unknown. This is very important, okay. So you see, in the previous method you were taking the forces as unknown, whereas if you want to analyze the same structure, using displacement method of analysis, then you should be considering displacements as unknowns, okay. So what displacement you should be considering? Let's say you should be considering how much displacement will be happening at this what is called at this support, fixed support, or how much displacement will be happening at this prop support, and you will consider that displacement is unknown, okay. So displacement is unknown means you will be putting the structure under such a condition where you will be allowing the structure to deform, and considering the deformation, you will be trying to find out that displacement instead of the force. So once you find out the displacement, from the displacement again you will come back to the reaction components of the structure. We will not get into the details of this displacement method now. Just for the naming convention, you must understand the difference between these two methods, force method and displacement method. Okay. And in case of the displacement method, see, in case of force method, I have explained you what is compatibility, and using compatibility equations you will be able to find out the unknown member forces or reactions. On the other hand, when you will be applying the displacement method, at that time you see the equations, whatever you will be obtaining, they will be obtained using the equilibrium of joints. We will not get into the detail of it now, and that is why the displacement method, that is why the name of the displacement method is also equilibrium method. Okay, that is why it is called also equilibrium method. Now see, in the initial part of the discussion, we have also termed the force method as flexibility method and the displacement method as stiffness method. These two things you should understand, what is the difference between this flexibility method and stiffness method. So necessarily the force method is the flexibility method, and and your displacement method is the stiffness method. So what is flexibility method? So flexibility method, what is flexibility? First thing you should understand, what is flexibility. So flexibility is nothing but the deformation due to unit force, right? So when you are deforming a structure, the amount of deformation will happen because of a unit force being applied on the structure, that will be termed as its flexibility. On the other hand, stiffness is just the inverse of flexibility or the reverse of flexibility. Okay, so inverse of flexibility means stiffness is the force required for unit deformation. So the amount of force required for unit deformation, you try to understand, the amount of force required for unit deformation, that will be called as stiffness, whereas the deformation, the amount of deformation which will be caused by unit force, that will be called as flexibility. Now you see, in case of force method, we are considering force as unknown, right? So if we can find out the deformation, so the deformation, if we find out, and using the deformation, if we apply the compatibility condition, we should be able to solve the structure. On the other hand, in case of displacement method of analysis, we will have to use what? We will have to use the stiffness of the structure, that is the force required for unit deformation. So you should see two definitions, two things very clearly, that flexibility. So flexibility, this term you must remember, this is very, very important. Okay, so flexibility is deformation due to unit force, whereas you see the stiffness, you must understand this difference. Okay, so stiffness is the force required for this and required for unit deformation, and you should understand this, that flexibility is used in the force method to obtain compatibility equation, because what we are doing, flexibility is deformation due to unit force. So if you remember, when we are talking about this prop cantilever, we are talking about deformation, right? So deformation due to the force whatever is acting on the structure, we are getting compatibility condition from this. So if we know how much is the deformation due to unit force acting on the structure over here, and if I know how much is the deformation due to unit force acting on the structure over here, in absence of this, and if I equate those two deformations, then I will be getting basically the compatibility condition, isn't it? So deformation at here and deformation at here. So unit force acting on the structure will be creating some deformation. So because of unit force, whatever is the deformation, if I multiply it with the amount of force, I will be getting the total deformation. So at a particular point where I am considering the compatibility condition, at that point, if the deformation is 0, I will just sum it up and make it 0. So basically you see what I am applying actually for analyzing a structure using force method, where force is basically the unknown component, we are using the flexibility of a structure. Okay, so flexibility is used in force method to compatibility equation. This you must understand. Okay, and that is why this method is also termed as flexibility method. Okay, on the other hand, if you see, if you consider the stiffness method, if you consider the displacement method, in that case I will not get into the details of stiffness method as of now. See, in case of stiffness method, the displacement will be used for writing equilibrium equation. So stiffness, in case of stiffness method, writing equilibrium equation, for writing equilibrium equation, what you will be using? Just the reverse case, the displacement will be using for writing equilibrium equation. Now you see, what is stiffness? Stiffness is the force required for unit deformation. So for unit deformation, if I know how much force is required, okay, from that, how much is the deformation, if I know, I should be able to find out what is the force. So that is actually stiffness method. So thus the displacement method will be termed as stiffness method. Okay, so that concludes our basic discussion on force method and displacement method, what we have started from here. But we will be now concentrating primarily on this method, that is force method or flexibility method or compatibility method. You have, I hope that you have understood, you have got some conceptual understanding about this thing. We will take up problems, we will take up theoretical concepts, and slowly I will be going for this analysis. But I must say, you must sit with pen and paper, as well as you should try to solve the problem. Okay, otherwise you will not have understanding of this at all, and later on you will see that you are getting confused for analyzing a very simple structure, just like you are just telling few minutes back a cantilever beam is a indeterminate structure. Okay, so I request all of you, please sit with pen, pencil, paper, and also calculator in front of you. Okay, otherwise it will be very difficult to understand. Okay, so the force method of analysis, now you see, I just come to the force method of analysis. So it is basically more detailed thing about force method of analysis. Force method of analysis, I have explained it to you, what is force method of analysis. But let me get into more detail. Should I have time? Almost 55. Just one or two line I'll explain, and then the force method of analysis, also known as, in many cases you will find that force method of analysis, as I have mentioned, that it is also called flexibility method or compatibility method. It is also termed as method of consistent deformation. This term also you will observe at many places. So the force method, so you must understand from these names that the name may be different, but necessarily the method is same. Okay, name may be different, necessarily the method is same. So this force method is also termed as method of consistent deformation. Okay, so this method of consistent deformation, actually what it does, I have explained you. So it uses, you see, basically it uses equilibrium equations and compatibility conditions. So mostly you must say compatibility conditions and equilibrium equations. So what are the equilibrium equations we have spoken about? So these equilibrium equations are nothing but the equilibrium equations coming from the statics, that is sigma fx equal to 0, sigma fy equal to 0, sigma mz equal to 0. So in case of force method of analysis, see, you cannot only analyze the structure using the compatibility conditions itself. You also require equilibrium equations along with the compatibility conditions. Then only you will be able to analyze the structure, which is basically a statically indeterminate structure. Okay, statically indeterminate structure. Clear? So let's stop here today, because I am not getting into the redundant and other terms, because in the next class we will discuss about all these things. What is redundant force, what is the primary structure and other things, and then we will get into details. I mostly discussed this part, but more detailed discussion we will be doing in the next class. Okay. So I request you, please go through all these things, whatever I have discussed in this class. Then only you will be able to understand in the next class. Okay. So let us stop here and take the attendance. See, please ask your doubts. Okay, if you have any doubt, you stop me and ask. Otherwise, it will be difficult for me to understand whether you are understanding or not. Mostly in the previous days class, I have seen many people are not listening to the lecture at all. Means even I have noticed students who are just switching on their mobile and they are not at all sitting in front of the mobile also. So I have identified those, and maybe in the next class I'll try to ask you also that what are you doing actually. I'll see. Okay. So thank you. Let us stop here today.